AC sine waves by DK. An AC waveform is a type of signal that oscillates between two levels in a set time sequence. The most common alternating waveform is the sine wave, which is essential in understanding alternating current. AC is widely used in electrical power systems that forms the basis of how energy is delivered to homes and industries. AC generation and sine waves. In an AC generator, mechanical energy is converted into electrical energy. This process involves rotating a magnet, the rotor, inside a set of windings, the stator. The rotating magnetic field induces a voltage in the stator, producing a sine wave. It can be expressed in the following form. Peak value, or amplitude, multiplied by sine of angular velocity multiplied by time with the addition of a phase, if that is applicable. Vm here is the peak value or amplitude. The omega is the angular velocity, which equals to 2 pi times frequency, and t is the time. The peak to peak value refers to the total voltage difference between the positive and negative peaks of the wave. A sine waveform repeats at regular intervals, as we can see. The time it takes to complete one full cycle is called the period t, and the number of cycles per second is the frequency, which is measured in hertz. These parameters are fundamental in defining AC waveforms. Phase relationships. When two waveforms of the same frequency are shifted in time, they exhibit a set phase relationship. One wave can either lead or lag compared to the other, depending on whether the shift occurs before or after the reference waveform. This phase shift is measured in degrees or radians, such as a sine wave leading or lagging a cosine wave by 90 degrees. Oscilloscope. An oscilloscope is a tool that is used to visualize sine waves. It helps engineers analyze the shape, amplitude, and phase relationships of AC signals, aiding in the diagnosis and understanding of electrical circuits. Thank you for listening to my TED Talk.